All right, so compound interest, there's three different formulas that we're going to use. But if you understand this, this is really the same formula, these two. So we have simple interest. So simple interest formula is A equals P times the quantity of 1 plus or minus R raised to the power of T. So A represents the final amount. P is the initial amount, okay, or our starting value, kind of like the A value was, the lowercase a in the last problem. And then R is going to be our rate, so this is going to be a percentage. But when we put it into our equation, we need to make sure to change it or convert it to a decimal. And then T is always going to be the time. So this is number 9 from the worksheet that's for Thursday. It says a population of Austin, Texas is growing at a rate of 3.9%. Okay, so that's our rate, 3.9%. This as a decimal is 0.039. So this is actually what we're going to use when we plug it into the equation. And it says if the population in 2010 was approximately 790,000, so this is our initial value, 790,000. Okay, it says what is the predicted population for 2015? So if we started our data at 2010 and we want to know how much it's going to be in 2015, the time that has passed between that is 5 years. Okay, so our time is actually 2010 to 2015. And so what we're trying to find is the final amount. How many people will there be after 5 years? And so I use this equation. Okay, this is what I'm trying to find, my final amount. I put in my initial amount. Okay, and then I do 1, since this is a growth, it's growing, it's going to be 1 plus 0.039, okay, and then it's going to be raised to the power of 5. All right, and so what I do is literally I just plug that into my calculator. Okay, so I do 790,000 times 1 plus 0.039 raised to the power of 5, and I hit enter, and it gives me an answer. Now, since this is people, I'm not going to have 0.7 people, so I'll just round up. So my final answer is going to be 956,544. So 956,544 people approximately after 5 years. Okay, and so what I will do is I've sent a link as well on the Canvas website, our little pacing guide of a calculator that's basically the TI-84. Okay, so it's just a Chrome extension. You just click on that link and download it, and you'll have the exact same calculator that I have right here. Okay, so simple interest versus compound interest. So you see simple interest formula again. Compound interest is very similar. It still has our final amount, our initial amount, 1 plus or minus. This is what is different now. R divided by N, and then raised to the power of N times T. Okay, so N is the thing that is new. N is how it's compounded within a year. Okay, so if it says, so these problems are going to say, hey, it's compounded yearly, well, then that would just mean 1. Okay, if it's compounded quarterly, so that means 4 times a year. If it's compounded semi-annually, that means it's 2 times a year. If it's compounded monthly, that means it would happen 12 times a year. If it says compounded like daily, then it is 365. Sometimes they also might just say, hey, it's compounded 5 times within that year. Well, N would be 5. Okay, so I'm going to work out a problem that I just found on the internet. It says Brenda invests $4,848 into a savings account. So that's our initial amount, $4,848, with a fixed annual interest rate of 5%. So our rate is 5%. As a decimal, that's 0.05. Okay, so we're going to use the decimal. And it says compounded 2 times per year. So that's where my N comes in. My N is going to be 2 since it's compounded 2 times per year. what will be the account balance after 6 years? So again, here is my time. So again, all I do is I rewrite this into my formula here. The initial amount times 1. Again, this is a growth plus 0.05 divided by 2 raised to the power of 2 times 6. And so I take my calculator, I do 4848 times 1 plus, and then to get a fraction bar, I hit alpha, y equals, and then there's my fraction bar, 0.05 over 2 raised to the power of 2 times 6. Okay, and then I just hit enter, and there is my my answer. And so since it's money, I will calculate to 2 decimal places. So this is 6,520.02. Okay, so that's compound interest. It'll tell you it's compounded a certain amount of times. Okay, and then the last formula that we need to understand is when it says it is compounded continuously. Okay, compounded continuously. Okay, so it's a different formula, but look at the variables that we're still trying to find. Okay, I'll explain this E here in a second. It's just a value that we're going to use our calculator for. There's actually a button for E. And so if I have a problem, it says Jasmine invests $2,658. So that is my principal amount, my initial amount. Okay. Into a retirement account with a fixed annual rate of 9%. So that's my rate, 9% as a decimal, 0.09. And it is compounded continuously. So that is the key word, continuously. If you read that it is compounded continuously, this is the formula we have to use. Okay, and so it says, what will be the account balance after 15 years? Okay, so again, all I do is I plug in my initial amount times E. There's going to be a button for E, and then raised to the power of 0.09 times 15. Okay, so here's my calculator. So I do 2,658, and then the E button is right here. Okay, it's E raised to the power of X. So to access that, you have to hit second, and then you press that button to access the E value, and then it all automatically gives you your exponent. So we put 0.09 times 15. Okay, and all I do is hit enter, and now we get our final answer, 10,253.04, because we'll round up. So my final answer, 10,253.04. Okay, so that's how much that lady would have in her retirement savings after 15 years. Okay, so hopefully this helps. Let me know if you have any questions.